Going, Roger Williams. Brain freeze. Author of The Metamorphosis of Prime Intellect. just mini stroke. I was like, where am I? What am I doing? The fuck is my name? Just every once in a while I forget what I'm doing. This incarnation on this planet. It's like, oh, I'm playing human. I'm doing podcast. All right, just remember the script, asshole. So
I got bad news about what happens when you get older.
Does it happen more? You know what? Fuck it. Oh, I can't reverse it, so you might as well grab it with, 2 hands and just be like, let's ride this bitch out.
All part of life's cool plan.
Yep. That's I have friends that use they use different cream on their face to look less wrinkly. They're already dyeing their hair. I'm like, dog, it's not, you're not stopping it, man. You're not stopping it.
Yeah.
Let it ride.
I don't do it. You might notice my hair is a little rough. I haven't had it professionally cut since about 1993.
You look goddamn beautiful, Roger. Shut up.
No, I used to have it styled, and that was back when I was a service technician, and so you're supposed to look neat and all. And I wore green Dickies with the name tag and all that.
Yeah.
But as computers got to be more of a thing in the industry where I worked, I started actually building systems for people and writing software. And I showed up one day for a job and told the secretary, our customer, I'm here to update the software in your scale computer. And she looked at me and said, oh, I thought you were here to spray for bugs. So
in a way,
that was the last day I wore the green Dickies.
Okay.
I bought myself some jewelry, let my hair grow, and started. All I do is when my hair gets in my bangs, I stand in front of a mirror and use a pair of scissors to cut it back so it's not in my eyes anymore. And amazingly, I probably saved tens of thousands of dollars
probably
over the years.
Probably, man. Go and get But fuck that shit. Just fucking ride it out. Who gives a shit?
I had a friend who started going bald in his late 20s, though, and the stuff that he went through trying to stop it was just unbelievable. But I have a coworker who had the same condition, and he just laughs it off. He just said, fuck it, shaved his head, and that was it.
I think that's what you have to do. I think if it starts going, I had a family member, an uncle, and started going bald when he was really young. And I think he really struggled with it for like 10 years, and then he was just like, fuck it. Just fuck it.
I mean, the last thing you want to do is a laughable comb over, right?
Yeah,
so.
I think you just got to go, I think you got to get a razor and just clean it. And just, plus when you are completely shaved, like bald, I mean, no one's going to fuck with you, because it's like no one knows. Is that guy bald because he's dodging like the, pattern baldness? Or is he an assassin? Yeah. It's one or the other.
Or is he flirting with the big C and we need to keep a distance? And
exactly. So it's dude. I've had on Dale Comstock on here, and he's a Delta Force guy. I've had him on this podcast several times. His head's completely shaved. I've never seen a picture of him without a shaved head, even like 30 years ago. So I don't. But that's someone where it's like, is it baldness or is it just because it's more efficient to kill? Like,
well, with those guys, they especially don't want long hair because it becomes a handle that can be used as a weapon against you.
Yeah.
So I understand that completely. Now my dad spent 2 years in the Navy, which he spent entirely teaching at the Naval Postgraduate School in Monterey, California. And to this day, he won't go to Applebee's and get the, on Veterans Day and he says, I don't feel like I served. I didn't go to combat or anything like that. But they made him wear a crew cut. And he just adopted that style, and he's worn a crew cut ever since. He's 79 years old, and he's still gives himself a crew cut now today. He's got the electric razor. And
hey, man, that's the way to go, dude. It's
all right.
Yeah, let's jump into it.
So anyway, I promised show and tell.
Woo!
So for my first thing, this is my radio.
Jesus.
Which I built in 2014 from a set of plans that was published around 1930 in Boy's Life magazine.
Jesus Christ.
It doesn't drive a loudspeaker, so you have to use an earpiece or a headset.
Yeah.
But you have your regeneration control, because this is a regenerative receiver, and the tuning. And of course, I am the kind of guy who had a multi-turn counting dial in my junk box.
Mm-hmm.
But to see the business end, this is your regeneration. When you turn it, it varies the amount of coupling between the tickler coil and the receiving coil. So what it actually does is it feeds the amplified energy from the output of the tube back into the antenna circuit, and that makes it both more sensitive and more selective about adjacent signals. And this is the tuning mechanism. Let me get this up here. This is a homemade variable capacitor. You can see those two, the sewing thread pulleys were part of the Boy's Life plan. Now, Boy's Life has done the build your own radio kit thing every couple of years since about the beginning of technology. And you can date the plans by that they use. This tube I will be getting to very shortly because I have some others similar to it. But you'll notice that there are very few pieces on here that I didn't build myself. In 1930, there were not a lot of junk radios that you could rob parts from.
Sure.
So this was designed to be built with stuff that you could scrounge, because this was published during the Great Depression. So there was an assumption you wouldn't be going off to buy parts. And having a collection of over 400 tubes from various eras and all, I wanted to just do something with at least one of them to prove that they are actual functional devices. And that radio actually works. The advantage that it has over a crystal set, obviously the family is not going to sit around it listening because it won't drive a loudspeaker. But the advantage it does have, if you're a kid and it's 1929 or 30, is that it will pull in stations that are fairly distant, which a crystal set won't. A crystal set will only pull in strong local stations. This receiver will pull in stations hundreds or even thousands of miles away if they're powerful enough. So in 1929, you could have used this radio. You could have been sitting where you are in Maryland and probably pulled in WWL in New Orleans on a good night with good propagation. So that was the idea. And I've seen some of their more modern plans. It's like in the 50s, they used miniature tubes, and they had parts that you would scrounge from dead radios because those were more common than dirt after a certain point. But that design is 90 years old. And the vacuum tube that powers it is about 90 years old, and it still works.
It's so you can you can listen to a radio. You can listen to a radio channel on that thing.
Yes. In fact, after Katrina, I used that radio because I realized a little too late that it was the only battery-powered radio left in the house. Actually, when Rita hit, I had just come back after they lifted the evacuation, and Rita hit and knocked the power out again, and I actually used that radio to make sure that everything was okay the morning after. Because now, if I was really using it a lot, I would have probably rebuilt it, because the variable capacitor isn't quite right, and it's heavily loaded toward the bottom of the broadcast band. It doesn't really receive the top of the broadcast band. But if I was a kid with an unlimited amount of time, I would have just taken it apart and used a slightly thinner insulator on it and tried it again until I got it right. But anyway, this related device. This is the oldest vacuum tube I own by design, and it is the second oldest by manufacturing date. This is an 01A, and one of the characteristics of the 01s was, you notice you can't see the interior elements at all. It's got this silver coating, and the reason for that is the silver coating is called a getter, and they pump it into the tube as the last step before they seal it up. And what it does is it mops up gas molecules that are still flying around. Maybe they were embedded in the metal before you sealed the tube and they become loose later. And the getter is made of a reactive metal like magnesium. So what it does is it gets any stray molecules that are flying around so that they don't gas up the interior of the tube. And when a tube goes bad, like this one, the getter turns white. Okay. Because it fully reacts, it turns into oxide. Okay. So you can see this is a dead tube. This has air inside of it.
Okay.
So this is the O1A. The original O1s made in 1922 when this tube was designed took 5 volts at 1 amp. So they used about 5 watts of power to heat the filament.
Okay.
This O1A, those were the 201s. This one is an O1A. It is a little later in the 1920s design. It uses 5 volts at 120 milliamps, so it uses about 0.6 of a watt.
Okay.
So it's much more efficient than the older ones, but it's exactly the same electrically as far as its behavior as an amplifier. It has a gain of about 8. So if you put a 1 volt signal into it, you get 8 volts out, which is crap by modern standards. But at the time, it was miraculous because it was an amplifier, man.
Yeah.
Now, our next exhibit is very closely related. This is a Type 30. This is the same tube that I used in the radio I just showed you.
Mm-hmm.
And this is essentially the same tube as an O1A electrically, but it's a later design. The design for this tube is late 20s. It's about 5 years more modern. And this one was actually made before my O1A, I think, though. I have some hints on the manufacturing codes and stuff. But this tube is essentially the same electrically. And I actually have articles that tell you how to take your old radio that was built for O1As and convert it to 30s, because this tube uses 2 volts at 60 milliamps to heat its heater. So it is 5 times more efficient than the O1A and 100 times more efficient than its predecessor. This tube is so efficient that you can't see it glowing. If you actually, the whole thing about you open the back of your tube TV set and you see the little dull red glow of all the tubes. I was very disappointed when I built that radio and turned it on, and I was like, why isn't the tube glowing? And I finally realized, because it's not supposed to. It's not visible unless you turn out like all the lights in the room.
Yeah.
So this is an example of the state of the art of electronic design around 1930. The O1A is widely considered to be the most popular tube of the 1920s. If you owned any piece of consumer electronics, which mainly meant you owned a radio, it was full of O1As. And there was a progression during the decade. In the beginning of the 1920s, there was no consumer electronics. There was no transmitters. There were no commercial radio stations. The entire industry didn't exist. Moving back in time to where I don't have any samples, when I mentioned in our last talk that Thomas Edison, of all people, invented the vacuum tube when he was trying to invent the light bulb. He discovered that you had a one-way current flow situation between the filament of a light bulb and a plate that was suspended in its bulb. It was Fleming who figured out that this would make a Boss radio receiver, because that's what you need in a radio detector, is to detect the waves one way but not the other, so they'll add up to DC and they can pull in the cone of a speaker or a headset. At the time, they were using things like crystal detectors, which were finicky, and you would have to find the sensitive spot, and which is a lot of fun if you're on a ship trying to contact someone because you're sinking. So the Fleming valve was much more reliable. But in those early days, in around 1900, all they had were what they called bright emitters, which meant that the filament glowed like a light bulb. It used a lot of power. That early O1A was a bright emitter. And the difference between the original 201 and the O1A was the thoriated filament, which didn't have to burn as hot to emit enough electrons for the tube's electronic section to do its thing. And that was a thing that was being constantly improved once the 20s came around.
Mm-hmm.
But in the 1900s, it wasn't understood very well. Now, it was Lee DeForest, I want to say in 1906, who figured out that if you put a grid of wires between that filament and plate, that you could put a small voltage on the grid and it would block a much larger flow, a much larger voltage trying to be conducted from the cathode to the plate. And that made it an amplifier. But DeForest didn't realize how his invention worked. He figured out how to use it as a radio detector, and it was much better than anything else that existed. And so he patented the crap out of it and jealously defended those patents whenever anyone did anything to remotely threaten them.
Yeah.
But all he knew about using it was that it made a really boss radio detector. He didn't realize it could be used for other things. And it was around 1910 that some other guys came along and figured out the actual mechanism by which it worked, and that you could build other circuits with it. You could do other things.
Mm-hmm.
So what the first really popular vacuum tube that there were a lot of was called the Type R, and it was made for radio sets in World War I. And that was a situation where they needed tubes that were rugged, that didn't have finicky controls. Some of the older tubes had like little bulbs that would release gas into the envelope. DeForest thought you had to have some gas in the envelope for it to work, and the people who came after, particularly Armstrong, realized that you didn't. Actually, it worked fine. In fact, it worked better with a hard vacuum. So they were easier to use. So the Type R hard vacuum valves were the first tubes in more than single-use case. They weren't handmade. They were manufactured.
Mm-hmm.
They had replaceable bases, so you could replace them if you got, you were getting shot at with this. They were made for use in war. But they still weren't consumer devices. That would come later. After the war, they still weren't consumer devices, but because they were being surplused, some radio amateurs got a hold of them and figured out how to use them to build transmitters that could transmit voice.
Mm-hmm.
And this was a big thing because most transmitters in the 19-teens were spark gap transmitters. And a spark gap is basically a switch. It shorts out, a bunch of current flows, and then the gap collapses and it stops.
Mm-hmm.
So it's what is called in tech speak a Class D negative resistance. Boy, you don't get to say that very often. The thing about it is it generates a shitload of noise, and it's a very messy signal. To transmit voice, you've got to have something that generates a sine wave, a pure tone at radio frequencies.
Okay.
And there were very few ways to do this. There was a guy who invented a very inefficient style of electrical arc that was mediated by a gas environment that could do it, but it wasn't very practical. And there was also a style what basically amounted to a dynamo, to a generator on steroids that could generate super duper high frequency current by rotating this like zillion pole thing at high speeds.
Yeah.
But with the vacuum tube, you can build a natural oscillator that generates a clean signal, and then you can modulate it so that on your crystal set, you hear a person talking or music. And by 1920, what you had was basically a few amateurs setting up experimental transmitting stations for the hell of it. And they would have a few friends that knew about it and would build crystal sets to listen or whatever, and word would spread. So if you were in one of these towns in 1922, there was probably maybe 6 of them in the entire United States. But if you were sufficiently motivated and you heard, oh man, this dude across town set up a transmitter, he's playing music every night, I want to get in on this.
Yeah.
Well, you would start building a simple set. You might build a set like that. Most of those early radios were what they call tune radio frequency. They didn't have regeneration. They didn't have anything fancy. If you did want the family to be able to sit around and listen, you would generally have 5 or 6 of those 01A tubes, though, to get enough amplification to take that microvolt radio signal and get it to a speaker where the family could sit around and listen to it. That was a situation in the early 20s. And then that set would be battery powered. There would be a 45-volt A battery that powers the plates of the tubes. You might notice I had 3 9-volt batteries over here. Actually, that's the B battery, excuse me. That powers the actual amplification thing for the plates of the tubes. Then you would have an A battery for the filaments. Because the filaments used a lot of power in the early 20s, that was a lead acid battery. And in fact, the Type 30 has a 2-volt filament. It's designed to be heated by a single-cell lead-acid battery. Mm-hmm. And you would take that down to the auto shop every once in a while to have it charged. Mm-hmm. The B batteries were a thing. You could walk into a hardware store in 1923 and buy a 45-volt battery, just like you can buy a 9-volt cell today, mm-hmm. because that was what the technology of the day required. So as the 20s progressed, these stations became more common because one guy would see that the guy 200 miles over there has got people listening to him and people are interested. So he would set up, and there wasn't a lot of variability. What these stations mostly did was they played vinyl records, and they did things like get the newspaper from Chicago and read it mm-hmm. over the air. They didn't have any way to record audio. They didn't have any other sources for programming. Everything was live. So that was the status through the middle of the 1920s. Now, toward the end of the 20s, it was getting popular enough that in some cities you could actually go into a department store and buy a console radio. Yeah. And in those days, it still generally required that you string up a long wire antenna and a good earth ground, or it wouldn't work. Excuse me. Some of them had regeneration controls. The thing about that regeneration control is you tickle it closer and closer, and it gets louder and louder and sharper until it bursts into oscillation and breaks your eardrums.
Yeah.
So that was not considered a consumer-friendly feature,
sure.
even though it was a very efficient way to make a sensitive radio. Some of them had a tuned radio frequency amplifier followed by a bunch of audio stages. Some would have 2 tuned radio frequency stages, but because the tech wasn't really up to ganging them together, you would actually have to tune them separately to the same frequency. Mm-hmm. So that wasn't a consumer-friendly feature either. It was in the 30s. During the 20s, there was a lot of research being done. The pentode was invented in 1926, but it didn't become a commercial product until later. It used a couple of extra grids to more efficiently amplify stronger signals, higher frequency signals. It eliminated some of the there were just other odd problems that are hard to describe without using a little math, but mm-hmm. the triode was a bit limited. So there were advanced designs that corrected this, but almost all of these tubes had this 4-pin socket, which is, if you think about it, this is the minimum for a triode. It's a light bulb, right? It's got 2 pins for a filament, a pin for a plate, and a pin for the grid. That's what makes it an amplifier. Mm-hmm. Well, during the late 20s, they started inventing tubes that had more elements. And so they needed more pins. And so for a while, there was a 5-pin socket, a 6-pin socket, a 7-pin socket. Well, the radio manufacturers ultimately got tired of that noise because they didn't want to stock 5 different styles of tube socket if they were going to use more than one type of tube in a radio design. Mm-hmm. So what ultimately happened was everything standardized. This one's missing a couple of pins that weren't installed, but this is the standard bayonet octal base.
Okay. Yeah, I can see it.
I think you can see. Okay, so it has 8 pins surrounded by a little cylinder with a key. And unlike the 4-pin, all the pins are the same size. And during the 30s, one of the things that happened is almost all of the tubes of the 20s that were still used for anything were reissued with different tube numbers, but it was the same tube mounted on the octal base instead of a 4-pin base or a 6 or 7 or whatever. So a 1V6 is a Type 30 on an octal base.
Mm-hmm.
But if you had in fact, that for a while they made adapters. So if you had an older radio that wanted a 30, but by this time it was like maybe 1935 or 1938, and it was easier to find the new standardized octal tubes, then they had adapters where you could buy the adapter, plug it into the old socket, and plug your tube into the top of the adapter.
Mm-hmm.
That was a thing that was that would go on throughout the 1970s. In fact, as tubes went generational, every change that was made, a lot of the old stuff was migrated and became the new stuff with different base styles and different envelopes and other little tweaks. But anyway, where were we going to go next with this?
I was thinking, like, what a weird, like technocratic elite, like the people that first knew about the radios and like playing music. Like everyone else that doesn't know about them, they don't know about them yet they're bathing in them. It's like right now, only you know that this song is playing, but everyone else is just fucking walking around like, look at the Model T, and it's like there's fucking jazz in the air, but only a couple know about it.
It was just like that. There was a sense of mystery about it because you were plucking these signals out of nowhere, and you had, and it was a two-way thing because you had the people putting the signals there, and so they were getting a satisfaction out of that, and then you had the people who were receiving them, and it was kind of snowballing, and it was encouraged by particularly David Sarnoff at RCA. He had a vision of a broadcast radio industry that would have transmitters and stations that were professionally manned and licensed and networked with networks of relay stations to share programming, and then that would create a market for receivers so that consumers who were not technically savvy could just go to the department store and buy a radio, take it home, put it on the desktop, turn it on, and listen to radio. It wasn't until the late 30s that it really became practical to walk into a department store, know nothing about radio, tell the salesman, I've heard about, there's radio broadcasts. I can hear the president talking with one of these. That was one of the big draws, in fact. You were probably the fireside chats. That wasn't just a good idea that Franklin Roosevelt had. It had never been technically feasible before. It was only possible because CBS had built a radio network that could share that real-time programming among all of its member stations. And that was one of the things that got a lot of stations joining the network, too, was to have access to things like that. And then once you have a network, you can do things like radio serial programs, and you can have a news department of your own and generate your own content.
And advertisements. Start putting out advertisements.
It was a thing that's... it was a thing that snowballed, and by the late 30s, it was you could go into a department store, buy a radio, you could just plug it into the wall. You wouldn't need to go out buying weird batteries. You didn't need to string up a long wire antenna. They had learned to use loop antennas in the back of the radio that captured the magnetic part of the electromagnetic wave instead of the long wire capturing the electric field. And that didn't catch as much energy because it was smaller, but what it did catch was more efficient because it was a magnetic detector and you had a coil instead of a single wire. And with amplification, it was good enough. And so you didn't have all of this setup. You could use it if you lived in an apartment or in a house on a small lot in the suburb where you didn't have room for the antenna. A lot of the early guys who were doing this were farmers, but so they okay, we need to run a 200-foot antenna. So, we can string it between here and the barn. That was actually, and of course, a lot of these guys were also what we call ham operators today. They were also operating transmitters of their own, but not for broadcast. They were doing just like contacts and stuff.
Well,
anyway.
I was going to say, right now, the fireside tweets.
This is one of the early power tubes. And this is also about a 1930s-ish design. This is an 809, and it's a power triode. And as you can see, it's like the type 30 there on steroids. Notice the cap on top was used because this tube was made to work at much higher voltages. You would use 400 or 800 volt B supply on a tube like this to get enough power out of it to create a strong transmitter. A lot of transmitters used pairs of these. Unfortunately, this tube is dead. I tried to get it to show on the camera, but on the very top, you see these ceramic spacers that are holding the internal elements. On the top of the top one, there's supposed to be two little springs that hold the filament in tension. And I tried before I logged on. I can't get the camera to show them. But one of those springs is actually rattling around inside the envelope of the tube. It's not connected anymore. So the filament on this thing is either already toast or is shorted out to something.
And there's no way to fix something in a vacuum tube, right?
Nope.
It's fucked.
The only exception to that is with very, very high power tubes like your 50,000 watt radio transmitter might use for your radio station. Those tubes are like this big and they're water cooled. And there is a whole technology of taking them apart and reconditioning them, but there are difficulties with that too. One of the big ones is the getter stuff. The silver stuff. Redoing that hard vacuum becomes a problem. One of the things they learned toward the end of the 1920s was after they sucked the vacuum down, but before they sealed the tube, they would put this thing in an induction heater and heat the entire tube up to where it glowed red. And that was to drive gases out of the interior elements so that it would hold its vacuum. I mean, it is pretty remarkable that this thing still has a vacuum after 90 years.
Yeah, that's insane. I mean, that's what blows my mind more than anything. That's what blows my mind more than anything is that they had goddamn vacuum tubes. Like, that is, to me, that's crazier than a radio, is that they figured out a fucking vacuum tube.
Yeah, well, and even there was a series of accidental discoveries, and then people figuring out why the accidental stuff worked a little more rigorously, and then finding problems and working out ways to solve them by let's adding another element to the tube. Let's have an indirectly heated cathode, so the filament isn't the cathode anymore. It's just a heater that heats the real cathode, and that gives you some advantages because a filament isn't all at the same voltage, because you have a voltage across it to make it hot. And the filament power supply also has to be at the same potential with the electronics as the electronic supply. So you can't wire all the filaments in your radio in series, which became a common thing to do later. So there was things like that, the extra grids. There's a special tube called the pentagrid converter, which has 5 grids. And it was designed to be the mixer in a super heterodyne receiver. So it was designed to fulfill a special function in a particular circuit better than individual tubes could. So you had all this kind of stuff going on. Now, that was consumer. In the pure research, military, industrial, you had research going on into higher frequencies. In 1920, it was thought that the frequencies above 3 megahertz, what we call short waves, because they're shorter than the medium waves of broadcast radio, they were thought to be pretty useless because they didn't propagate reliably. And during the 20s, it was learned that they do, in fact, propagate reliably if you learn how the ionosphere works, and that some propagate well at night, some propagate well at day, some propagate well at dusk and twilight and all. And they were working all that out, and that's where the whole shortwave thing came from. And they went from being useless to being a bastion of long-distance communication. Most ship communications went from being long wave to being shortwave, because the equipment was smaller, the antennas were smaller, there was just more bandwidth available. Because another thing they learned during the 20s is that when you modulate a radio signal, it spreads out. It actually takes a chunk of spectrum. It has sidebands. And the existence of sidebands was theorized, but it wasn't proven until the mid-20s. And sidebands limit the number of radio signals that can share a certain amount of spectrum. That's why spectrum is considered a valuable national resource nowadays. You know, when the FCC has a spectrum auction, that's what that's all about, because you can only put a certain number of radio signals in a chunk of spectrum space. And so the broadcast band only has room for about 100 channels, as it turns out. And as a practical matter, most receivers aren't good enough to receive two of them that are right next to one another. So they actually make an effort to make stations that have adjacent channels distant from one another.
Okay.
So there are regions of the country that are literally designated for odd and even channel range assignments.
Is that so?
This was all done. This was all worked out in the 20s and 30s when they were doing. There was a bunch of theoretical work behind it, and at this point, so as we get into the 30s, they're realizing the shortwave is not only useful, it's real useful, and everyone wants to use it. And you've got the pure researchers have moved to what they call the very high frequencies, VHF.
Yeah.
That's an acronym you've probably heard.
Yeah.
Those start around 50 megahertz and go up to a couple hundred megahertz. And one of the first things they learned when they started messing around with VHF is that these phenolic bases that they were mounting the pins in, they start to conduct electricity. The plastic starts to parasitically conduct electricity. So for a few years, they made these. And that is a tube with a ceramic base.
Okay.
And because ceramic doesn't do that.
Okay.
These are rare. If this tube was new in its original packaging, it would be worth at least $300.
Jesus.
As it is, if I tested it and guaranteed its provenance as far as working correctly, it would be worth around $100.
Versus how much? What was its price?
Versus more
debuting?
like, if it had a phenolic base, it would be worth about $20.
What
in
was
today's
it?
market.
What is it when it came out? Is that what you're saying? 20?
This is a model 801, or its military designation VT62. This was another common transmitting tube in the early 30s. But they didn't make ceramic bases for long, because eventually they figured out how to make the pins come straight out the glass, and that solved the problem more effectively. They also found that it took time for the electrons to travel from the filament or the cathode to the plate. And they don't travel at the speed of light. They travel quite a bit slower. So the electrons start crawling away past the grid, and then the signal reverses. And then so if at high frequencies, the electrons never make it. So the tube stops conducting electricity. So they started making them smaller. This is called a pencil tube, because it is the diameter of a pencil.
Yeah.
And these were made starting in 1940, and they're considered a very high quality product. They're really rugged. They have really good longevity. This one has never been installed, as you can tell, because it has pigtail leads. They're visible there.
Yeah.
So this tube wasn't designed to use a socket. It was designed to be permanently mounted.
Okay.
And soldered in place.
Okay.
And so it was a matter where you would have whatever assembly you made with these, you would replace that instead of the tubes. They were considered that reliable that they were worth using in that way. But these never made their way into consumer devices in any meaningful way. They're too expensive. But what they were used for was very high frequencies. I have a group of these that I pulled out of a VHF transmitter, which saw service in Vietnam, and I bought it in the surplus market in the 1970s after the war ended. And it was chock full of tubes like this, and also this style, which is a little harder to show, but it has a flat base.
Okay.
And I think if I get it here, you can kind of see that it has
I can see it.
4 or 5 pins.
Yeah.
And the one place where I've seen this style of tube in a consumer device was in a hearing aid.
Okay.
That I was given by one of my friends when I was young. And that amplifier was about the size of a pack of cigarettes. It had one of these tubes in it. Of course, you would wear it in your pocket, and it had a wire to the earpiece. But in those days, that's they didn't have electronics that you could actually stick in your ear, so that's how you did it.
That's so like steampunk. Get your your earpiece connected to your pocket. Yeah.
So anyway, moving toward World War II, you had research into really high frequencies, and so you had a brief flirtation with these guys. This is called an acorn tube.
When I was gonna say, don't rush through this. Like we're gonna have to do, because like I still have time tonight, but I'm gonna say don't rush through this because we can do a part 2, 5, 10. Let's do it thoroughly. Okay. I don't want you to rush through.
I'm not even halfway through.
Good. Don't rush. Yeah, don't rush. Don't rush through. Let's do it thoroughly.
Yeah. Good. We got a whole century to go.
We got. Podcast isn't going anywhere. Okay.
So this is called an acorn tube.
Okay.
And this was strictly an experimental research type thing. You'd never see these in consumer devices at all. They were used to do early microwave type research in radar, what they called UHF then. And one of the goals was not just to have teeny little elements. You can't see it. In fact, I can't see it with my own eyes, but the plate of this thing is basically a flat sheet with a teeny little, less than a millimeter wide bump in the middle.
Okay.
And it's a triode. In the middle of that bump, there is a grid between the cathode and the plate. I cannot conceive of how they manufacture things like this. And they also keep the leads away from each other. Okay. Unlike normal tubes where they're all sticking out the bottom, these are spaced apart so they won't couple to one another when they're installed in an assembly.
Okay.
But again, they learned how to do better versions of stuff like this. I only have a couple of these, and I will never build anything with one of them. I wouldn't begin to know how. But that's closely related, though, to what is probably the only tube left in your house. You used to have 2 tubes in your house. One of them was on the front of that thing you use to watch movies and shows, the television set.
Cathode tube.
Because the cathode ray tube is a vacuum tube.
Yeah.
And until about 2000, it was the only way known to display a picture in that way.
2000?
And that's why you didn't have flat screen television sets.
That's why? Jesus. So
that is the reason.
So I'm old enough to be like. So I'm old enough to be. I was 10 when they had flat screens around. Yeah. Oh Jesus!
See, this is another style of. This is also a cathode ray tube, and it's a little more typical because this is from a small oscilloscope. So you have electrons. This is literally called an electron gun that fires a beam of high-speed electrons toward this phosphor face. And in a TV set, there's a magnetic yoke around it. In this one, there are electrostatic plates that you put voltage on that steer the beam. They can move it back and forth and up and down. And that's how it creates a raster. And it modulates the electron beam strength to generate a weak dot or a bright dot. And using that, you can draw a picture on one of these. And that is how television worked until very recently.
Jesus.
So, and this thing wants a 2,000 volt power supply at enough current to kill you just as dead as an AR-15. So you do not want to mess with these things if you don't know what you're doing.
It's truly a gun, yeah. It'll kill you.
Yeah, it's electron.
It's a gun.
Yeah, believe me.
Yeah, it'll kill you.
And the military guys have been having wet dreams about using something like that to shoot shit down for 50 years.
SDI, Space Defense Initiative, or Strategic Defense Initiative.
Yeah, it was strategic.
Oh yeah.
Now World War II comes along, and you have the same problem you did in World War I, which is people are shooting at you, but you are more dependent on electronics than ever, because communication is the backbone of every military operation in World War II. We were familiar because of all of the the romance around it with the code breaking and all. But just getting the signals from point A to point B was a big deal. That is when these guys showed up, and that is a metal jacket tube.
Okay.
This is electrically the same. This is a 6SJ7, and this is the same tube that was also sold in a glass envelope. But you wouldn't see a metal tube like this in a consumer device, even though you might use it and it would work if you installed it, because this tube costs twice as much to manufacture as a glass envelope tube. But where you see these is in maritime equipment, military, industrial stuff that's subjected to extremes. All during the 40s, they were putting electronics in extreme situations that had never been attempted before, and learning how to do it and get away with it. And so that's where you came up with these miniature designs, that guy. But it was a strange mix because you had a lot of research into fundamental principles, some of which, if they saw a reason, was immediately applied into war devices. You had new circuits being done for radar assemblies. The other tube that you still have in your house is the one in your microwave oven. That is a magnetron, and it is a special design tube. It's not a normal grid plate to design. It's something. There's a lot of math behind it, but they get the electrons whirling around in a circle in this powerful magnetic field, and that generates high frequency radio waves, and they use that to cook your food. That is still the state of the art for generating high power microwave energy today. So if you ever junk a microwave oven, don't forget to take it apart, because the magnets from a magnetron tube are rad. They are the best refrigerator magnets ever.
Really?
They're donuts. They're about that big in diameter, and they stick to your refrigerator with good 3 or 4 pounds of force.
It's like those neodymium, or how do you say it? Neodymium magnets?
Well, the thing about refrigerator magnets is they're not rare earth. They're ceramic magnets, but they are massive, gnarly ceramic magnets. So they're not as dangerous as the rare earth magnets. I mean, those things will put a hole in your hand.
Those will blow your hand apart.
The magnetron, the magnetron magnets won't do that, but they will hold your shit under the refrigerator like nothing else.
They will hold your shitty artwork there for years.
Yes. So we come out of World War II, and there's a big pent-up consumer demand. And one of the things, of course, is radio sets rapidly get optimized and improved. It was actually toward the end of the 30s that a design called the All-American 5 was invented, which uses 5 vacuum tubes. And it was optimized to the teeth to minimize the number of components. All the filaments were in series, so the tubes had to be special made for that design, so that all their filament voltages would add up to 110, and they would all come on with the same curve, so that one of them wouldn't hog all the voltage and burn itself out while the set was being turned on. And there was a tension about that design. And in fact, I own a radio from the 30s that was made by, United American Bosch. I have the schematic behind my computer here. That company went out of business because the owner refused to build the All-American 5. He said it was a shitty design. He wasn't going to put his name on something that cheap, and that basically it was, they didn't have the word hack in 1935, but that was what he thought of it as. But at the same time, he couldn't compete with his competitors that were making this cheap design and putting it in an ice cabinet and selling it in the same department store as him. So I have one of his last radios that's built with a chassis and a transformer and construction very similar to how shortwave receivers were still made in the 40s and 50s. But consumer radios all pretty much became the same really kind of mediocre design. And it's one of those things, if you were working on radios in the 60s, you knew about this, because no matter who made the radio, they all had almost exactly the same circuit, the same capabilities. None were really substantially better than any others, and they all tended to fail the same way. So as a service person, you didn't even need a schematic diagram to figure out what was wrong with one of them. They were all the same. So anyway, that's about where consumer electronics was, except for television. Now, in the early 50s, television was about at the same point where radio was in the 1920s. There were a few experimental transmitters. There were a few receiving devices available that were very expensive. There were hobbyists who tried to roll their own. There were literally people who made television sets that could receive a television signal and display it on an oscilloscope tube, because that's what you had available if you were an amateur.
Yeah.
And the TV set is much more complicated than a radio. So what happened was tubes started proliferating. They started designing special tubes to do the particular functions that a TV set needed as efficiently as possible. So that was where last week I showed you the horizontal deflector. The fact there is a type of tube called a horizontal deflector tells you that is an entire class of tube. It was designed to do one thing, and that was drive the horizontal magnetic yoke in a television set.
Jesus Christ.
So there were other tubes that were designed to be the power amplifier. There were hybrid tubes that were designed to do some of the tuning and intermediate frequency functions to extract the signal. And by the mid to late 50s, the design of TV sets had more or less standardized to where they mostly all had a similar mix of components, and they cost about the same, which was probably about what you would pay for a decent used car for a 19-inch television set. And that was before color.
Jesus Christ.
And it followed the progression that radio had, which is you had the early adopters, and they would invite their friends to come sit around and watch TV. Most cities might have one TV station. And unlike radio, TV signals really don't go over the horizon. So if you lived in a city that didn't have a TV station, you couldn't even buy a TV. No one would bother trying to sell you one. But once you had a TV station, the early adopters would come in. Even if there was only one TV station, they would buy a TV so that they could say, I have a television set. And that would get their neighbors interested, and then someone would start another station. Now, back in the radio days, I mentioned the networks. The first radio network was the Columbia Broadcasting System, and NBC and ABC were formed a little after, about the same time, and they each put up their own set of relay stations to distribute content, because they all had the same problem. Audio recording didn't come into its own until after World War II. In fact, practical audio recording was invented by the Germans during the war. We didn't have access to it until the war was completely over. If you've ever watched an episode of Hogan's Heroes, you might notice that every once in a while they pull out a wire recorder that can play back an audio spool of wire. And that was the state of the art at the beginning of World War II. And it didn't work very well. The wire was noisy. It was difficult to erase properly. Basically, they were single use unless you did some fancy shit. They were hard to thread and use. It was totally an experimental thing that was not suited to commercial or much less consumer use. Mm-hmm. And it was during the war that some German researchers figured out how to deposit magnetic oxides on flat tape, and that this worked a lot better. And they designed better read and recording heads. And when the war ended, we got access to this technology. And within a few years, that started to be the basis of time shifting, not so much for consumers as for networks. So you could have a newscast that was broadcast on the East Coast and record it and play it at a more reasonable time for the people on the West Coast. That was impossible before World War II. The technology didn't exist.
Fucking Nazis.
So, yeah, we owe tape recording to them.
You hate to admit it, but Operation Paperclip, you hate to admit it. It's a great book, by the way. Operation Paperclip by Annie Jacobson. I think you would like it.
Yeah, I'm familiar with the story. Yeah. I haven't read the actual book.
The book, it goes, rockets were just, that was just what everyone knows about. We got everything. We got all sorts of shit from them.
Well, in order to make the rockets work, they had to do a lot of other stuff. And that's where I'm familiar with some of that, too.
Yeah.
The reason that rocket science became slang for something only really smart people understood was that they had invented so many new things, a lot of them involving really advanced math, particularly guidance systems.
Yeah, just to bounce that fucking explosion, just to go straight up.
Yeah.
Yeah.
Yeah. Well, it actually was to go straight up and then come down in a particular place.
Maybe
which
London.
Mostly did.
Just throwing out a random place, maybe London. Yeah. I don't know.
And of course, von Braun had this deeper goal of exploring space, and actually drew designs for more advanced rockets that, after the war was done, he was hoping that they would be able to pursue. Mm-hmm. And then, of course, Operation Paperclip got him. He came here and moved to Atlanta. But yeah, that was why his biography was often mockingly called "I aim for the stars, but sometimes I hit London."
Yeah. It's Jesus. Fucking von Braun.
So anyway, in 1950, television was at about the same place that radio had been in 1920. It was impossible to record a television signal. So if you had one of those early television stations, all of your programming was either live or it was broadcast from film, from actual photographic film movies. Mm-hmm. And it took them about 5 minutes after television was invented to invent a way to broadcast 24-frame movies over the 30, 60-frame TV system. Mm-hmm. And that was the basis. All of your early TV shows were shot on film because there was no video recording. And when video recording was invented in the late 50s, it was very difficult to edit because you had different heads doing different things. So if you wanted to cut the tape and splice in something else, it wasn't a possible thing. So again, what they mostly used videotape for when Ampex made it work was for time shifting the newscasts and stuff like that. So they would broadcast a show, maybe a live action show, like a sitcom that's filmed before a studio audience. They would simply record the whole thing in one go, and then they could play it back for the people in the West Coast after they had finished eating dinner and whatnot. But that was what drove the next wave of interaction. Was they figured out how to hack color into the NTSC television signal, which is one of the great hacks of all time. Making a color signal that a black and white TV would receive and display properly was something a lot of people didn't think was possible. And it involves some gnarly compromises.
Yeah.
I've had to take a dive into the NTSC signal because I actually use a microprocessor called the Parallax Propeller that has special circuitry in it that's designed to generate video signals from software. Mm-hmm. So it can bit bang video. But to do NTSC video is like, man, there is some crap involved with that stuff. And then God help you if you're from Britain, because PAL is completely different. Every country came up with their own standard, and none of them are remotely compatible with one another. They all have different limitations. And because we were first, we had the crappiest TV signals on the planet because we had designed our system first, and then everyone else came along and saw what was wrong with it and made improvements.
Yeah.
So the British system does color better. The Japanese system has more lines and higher resolution, and so everybody's TV looked better than ours because we invented it.
God damn it.
At least until digital.
Yeah. So if we're getting into video, it just raises the natural, because it's like there's always the first thing that happens with this new technology, right? And the first thing is always, how do we put it into war? How do we make it so we can kill the people that look different than us, right? Right? That's the first thing. What's the second thing? How do we use it to do sex? So one was the first pornography. That's always the first two. It's kill everyone else, and how do we fuck their wives? That's always the progression of technology. Yeah. Fire,
TV, television was actually kind of unique in that it does that backward. television became possible mainly because of technological advancements that were made for unrelated reasons during the war. So all these high-frequency transmitters that you needed, and high-powered, high-frequency tubes, and the mixer tubes that you needed, and all of the specialty hardware was there to be adapted into something that became relatively easy to manufacture. Rather than doing it all up, it would have been way too much of an investment for any private company to come up with all of the stuff necessary to do television. Now, as for pornography, that started on film.
Yeah.
Seriously.
Yeah.
And as far as well, we're getting a little ahead of the other story here, but porn was all film. Specialty porn was sold on 16 millimeter reels, and you would have to have a projector to watch it. Mm-hmm. Then in the 70s, you had what they call the golden age of porn, because you had people making 35 millimeter print movies with a crew. A lot of those crew members that worked on porn movies actually went into regular Hollywood later using their experience, because you had to know how to work the equipment. It was all the same stuff used to make professional movies. And when video came along, the first thing they did was they took all of those film movies and videotaped them and sold the videotapes. But then they started using videotape to film the porn directly, and it got cheaper, and the standards got lower, and that's before even the internet came along.
And now you have the
computer video.
Yeah, and now you have those perverse corners of the internet where anything goes. Just
actually, you had them, but a lot of them got struck down. That's another story. Sometime I'll have to tell you about insects.
The what?
But getting back to radio.
That's another episode. Okay. Yeah, that's another episode.
Yeah. Oh, that's a story.
That
is a beautifully perverse, wonderfully perverse story. But getting back to television, as we approach the 60s, the driving force behind consumer electronics becomes television, and what they called hi-fi, high fidelity audio recording. Record albums were standardized during the albums. The first standard albums were done in the 30s, but they were 78s, and they would only play one song. So they were like a 45 was later, but they were this big. And they miniaturized the recordings. Then they came out with the slower turning ones that could play more sound. And there was a whole evolution of that stuff in the 50s and 60s that ended up where we are today with the 33 RPM record that could play about half an hour to 45 minutes on a side. Mm-hmm. Then transistors were invented. And the first transistors were invented in the late 50s. And what immediately happened was almost nothing. I happen to have this. This is really hard to show, but this is a fairly early model transistor. And I don't know if you can see that little kind of flattish metal case.
Yep.
This puppy would have cost more than a vacuum tube when it was new, and did a lot less. These things were very fragile. You could take one of these tubes. I was involved with people who tuned their transmitters wrong and had the plates of these tubes glowing orange. But the tube survived. They throttled it down, figured out the problem. You do that with a transistor, and the smoke comes out. Mm-hmm. Plus, this transistor might have cost twice as much as one of these Type 30 vacuum tubes in 1957. Mm-hmm. Now, that wasn't very attractive for consumer devices because you had this very mature technology. But where you did see it was computers. Mm. Because these things also were very crappy. They had very crappy audio quality. They're not very linear. They have very poor response when you go off the ends of their curves. Basically, they're finicky. They're hard to work with, and they don't work very well even when they're working. But when you build a computer, all you need the damn thing to do is to act like a switch. Mm-hmm. You want it to either come on and conduct or go off and not conduct. Nothing in between matters. Mm-hmm. So these crappy early transistors were just fine for the computer industry. And you got to remember that when you were building a computer in the 50s, you might have 20,000 of these. miniature vacuum tubes. And these things have a mean time between failures of $10,000 to $20,000. If you do that math, it basically means you have to have elaborate circuitry to detect a failure and a service technician on site all the time to fix the thing when one of these needs to be replaced or anything else fails. They were doing really elaborate stuff with mercury delay lines for memory, and those would get out of calibration. Early computers were just monstrous devices. Yeah. And that led to one of the more famous dumb things smart people say quotes of all time. Alan Turing and John von Neumann are basically the two people that I would personally credit with inventing the computer. Yeah, von Neumann. Turing built the first one in Britain to solve the Enigma codes. Yeah. And von Neumann built the first one in the United States to see if they could build a hydrogen bomb by doing the hydrodynamic calculations. Yeah. And von Neumann famously told a magazine reporter that computers were amazing, wonderful devices that made almost superhuman feats possible, but that they were so elaborate and expensive that there would almost certainly never be more than 10 of them in the entire world. Needless to say, that came back to bite him.
And yeah, because he in Richard Rhodes's Dark Sun, a book about the hydrogen bomb, they talks about von Neumann. Yeah, and von Neumann was like, he's like, these are.
He was real tight with Ed Teller and Stanley Ulam.
Yeah, and von Neumann apparently was like, this is crazy. He's like, he was like, some of these computers, he's like, I mean, these might have up to like 60 kilobytes of memory, and people are like, bullshit. And he was like, yeah, 60. They're like, my God, sir, you get you to the Pentagon.
Yeah,
and he did.
So anyway, these early transistors were very attractive to the computer industry because when you're talking about something that big, you're spending millions of dollars on it. You're spending hundreds of thousands of dollars a year to keep it in operation. And for that, the difference between well-designed, mature vacuum tubes and crappy early transistors still massively favored the transistors. And so the early computer industry sucked up the entire world supply of transistors for many years, except for one application, and that was portable radios. Mm-hmm. For portable radios, the fact that the audio quality was crap didn't matter. What mattered was battery life and lightweight, so you could take it to the beach and play it all day on a set of batteries. For that, vacuum tubes didn't cut it. So the transistor radio became the transistor device that you might own as a consumer, individual. Not for set-top radios. Those stayed vacuum tube until the late 60s. Not for phonographs, not for television sets. There was no reason to use a transistor in any of those things. Because once you have said, well, I need to use vacuum tubes anyway for the final output to get enough power, or for the preamp because it's got to be linear and the transistors aren't good enough, then it doesn't make sense to use transistors for anything, because then you've just got a whole separate power supply for them, a whole separate set of engineering problems. The only exception that I can think of to that were in the early 70s, portable TV sets started to use transistors for some of their circuitry. And again, it was portability. So even though you couldn't get rid of all the tubes, you could get rid of the low-powered ones and still make a 12-inch TV set that a teenager could carry around. Mm-hmm. As I know, because I had one of them. It had like 3 tubes plus the picture tube and a little circuit board full of transistors. And it was expensive because transistors were still a premium item. Mm-hmm. So you had that going on. So transistors didn't really change consumer electronics very much, except for this one new product that the kids took to the beach. And you'll notice they weren't playing Mozart on those things. They were playing rock and roll. So they didn't care if there was harmonics being introduced and the audio quality wasn't perfect.
Yeah.
So you had that. All right, so let's see where I just had one of those brain farts because I knew where I was going with the story next.
Transistors, portable radios, batteries.
So So
ENIAC von Neumann.
Yeah, they had computers. 20, videotape.
20,000 things in one room.
Yeah. In the 50s, they finally learned to record video signals, which, if you recall, after the war, that was one of the big things with audio, was being able to record and play it back.
Sure.
The problem with video is that it's very high frequency, so the tape has to move super fast. On audio recording, the faster the tape moves, the higher the fidelity. So on the old, like quarter-inch audio decks, there would be a selector for the tape speed. You could set it to a high tape speed, which would give you good quality, but the tape wouldn't last very long. Or you could set it for a low tape speed, which gave you a crappy quality, but you could record for a longer period of time. Yeah. Well, television required, RCA, the engineers wanted to give David Sarnoff a birthday present. They wanted to give him a video recorder. They wanted to invent video recording. And as one of the books that I read on it said, by the time Ampex actually solved the problem, RCA's demo was going at the speed of sound. They actually had to wear leather gloves to stop the tape when they wanted to stop it. It was moving so fast. Jesus. But what Ampex discovered was that they could take a wide tape and spin the head to make a helical track that would go in a pattern like that. And the head would then be moving fast enough to record the video signal with enough fidelity to play it back. And they invented this in the mid-50s. But Ampex was an American company. They were totally devoted to vacuum tube manufacture. In fact, I read a story that said engineers at Ampex had little plates on their desk, little signs that had helped stamp out transistors. So an Ampex video recorder was an installation. It was the size of a desk full of electronics. And if you were a TV station, though, it was worth its weight in plutonium.
Sure.
Because you couldn't take it in the field. You couldn't take it on the set of a TV series to film with it. It was something you would have as a studio tool.
Walter Cronkite shit, right?
Yeah. And also there were problems, like a lot of the Ampex recorders wouldn't play a tape that was made by another Ampex recorder. They could play their own tapes, but if you brought one in from another studio that was made on a different recorder, sometimes they wouldn't play because of little differences in how they were aligned and all. And Ampex wasn't really interested in fixing this because they had a patent and they were the only source for this thing. Does that sound familiar? This has been the case a couple of times down the road. Well, the Japanese were watching over their shoulders, and the Japanese were not afraid of transistors. So one fine day, the Japanese managed to enter the market, got over the patent thing and all, and they took this desk and shrunk it to where it would fit in a suitcase. So it became portable. And then they developed cassette loading mechanisms, and they fixed the problem where one player wouldn't play what another had recorded, and they basically ground Ampex into the ground. Mm-hmm. The American company that invented video recording went out of business because of Sony.
Jesus. Hey man, live by the sword, die by the sword. The Nazis invented the rockets, and we were like, "Get over here, bitch! It's ours." As the Reich falls. Yeah. Comes around again.
Yeah.
TVs. Yeah. The rest of the world is like ours.
They also invented audio recording. And so we invented video recording, and then the Japanese took it from us because we didn't have any companies that were willing to do it.
The circle of life. Yeah. And then China had the most COVID deaths, and we were like, fuck that. We're going to take it. So
yeah, we're number one.
Number one. Doesn't matter what it's for, bitch. We're number one. Nuclear arsenals, number one. COVID deaths, number one.
Yep.
We'll take it all. It's that. But I was gonna say, what a beautiful analogy for it's the faster the tape spins, the shorter the lifespan, but the better the fidelity. Like, what a beautiful analogy that is to like rock stars, though, right? It's like live fast.
Yeah.
The 27 Club, Jimi Hendrix, Mac Miller, Amy Winehouse, was Avicii, I think. It's you're in and out. 27, Kurt Cobain. Yeah, high fidelity, but it's done before it's.
Yeah. The candle that burns brightest burns fastest.
It's a beautiful analogy.
But that used to be a thing everybody was familiar with, because when tape recorders became consumer items, my dad had a 1/4-inch reel-to-reel that I inherited, had beautiful vacuum tube sound. But yeah, you had that speed selector, and that was always an item. Do I set that sucker for fast and have it sound good, or do I set it for slow and use half as much tape? That was, especially when you're paying $7 for a reel of tape like this, and it only lasts 15 minutes at the fast speed. And this was $7 in 1960.
Yeah. But that's what I do with my video right now. Uploading it. I upload to YouTube, BitChute, DTube, VO, and it's like some other, just so I diversify, just so one of the companies can't, shut me out because of wrongthink. Well, YouTube it's obviously the biggest and has the most access. It's free. I upload the high def, high quality, high audio fidelity to all of those. BitChute, DTube, and VO, I upload the video file I put on YouTube 7 to 10 gigabytes per episode. Those other ones I do, they're all under 500 megabytes. And yeah, it's I have limited time. I have the internet that I have. I don't have fiber. I don't have satellite internet. Yeah. It's kind of the same, right? It's the same. What do I want? Where am I going? What game am I playing?
Actually, mathematically, it's identical, because the problem is that you're paying. The reason that the tape at the faster speed records at higher fidelity is that there are more magnetic particles per unit of time there to capture the finer variations in the audio. And the same thing is when you devote more disk space to a file, then there's literally more bits there to devote to the fine shadings of video from frame to frame, and from the fine changes in the audio stream. And even with all the compression that we do, you still have that trade-off at the end.
It is. It absolutely is. It's a 10x magnitude often for me.
Now, I honestly, coming from my perspective, as far as computers and multimedia. So when I started using computers, I've mentioned this in our earlier talks, they were stupid. They were really, really stupid. And the idea that you could use a computer to listen to audio was just like that. That's like taking a Porsche and using it to pull your boat. It's just like nobody's going to do that. It's just not what it's for. And I was, to this day, I remember my sense of astonishment. I got a computer in 2003 because I had to make a couple of trips to Mexico. And I wanted to have a computer with me that I could use to get on the internet and take notes and stuff. So I bought the smallest portable computer I could find at the time, which was a 10-inch. And it had an optical drive. And I remember bringing it home because all I was really interested in using it for was surfing the web, or actually getting on the internet at that time wasn't synonymous with surfing the web. There were other things. Using the word processor and stuff. And I got home and found out that player was a DVD player. It could play a video. And I'm like, get out of here.
What the fuck?
I was like, no, I don't. That's bullshit, right? So I got one of my DVDs, put it in there. Player comes up. God damn it.
God damn it. Welcome to the future, bitch. You right?
And but that's been another progression as computers. People don't realize how far computers have come. When the MP3 compression standard was first invented in the early 90s, a typical computer could not record an MP3 and encode it in real time. You would record your 5-minute song in WAV format, which might take 50 megabytes. And at that time, 100 megabyte hard drive was a big thing.
Yeah.
So this was a hobby. So you would record your audio in WAV format, and then you would set the encoder to encoding it, and you would come back a couple hours later, and it would finally have encoded your 5-minute long song because of the computational resources that are necessary. It's doing a Fourier transform, which is basically a very complex mathematical operation to figure out what frequencies are present at what energies in the audio signal. And so recording the MP3 requires doing all of these Fourier transforms, which are like, in the 80s, that was like the benchmark of computer performance, was how long does it take to do a Fourier transform? That was like one of the hard problems that computers don't do well. And to make an MP3 file, you had to do tens of thousands of Fourier transforms per second. So as computers got faster, that got more and more practical. But playing it back was a different story, because to play it back, all you had to do was read that list of frequencies and reconstruct them. So you would have a bunch of virtual oscillators, and you would read this list of frequencies and set all your oscillators up for the right amount of energy, and then you would read the next time slice and do the same thing. And that was something computers could do even in the early 90s. Mm-hmm. So that was a thing. It was not really until almost the year 2000 that ordinary desktop computers could record an MP3 in real time. That was one of the things. The fact that we have handheld MP3 recorders now, that wasn't possible until the mid-aughts, because you're not only asking a computer that you can buy and isn't a mainframe computer to do it, you're asking something battery-powered that you can hold in your hand to do all these calculations. And, of course, now we're used to our phones being able to play video, but that was also a thing that used to be considered laughable. Yeah. And now we completely take it for granted.
Yeah, it's...
So,
I mean...
flat television screens were the holy grail of the electronics industry for over 50 years. No one had any idea how to make one.
Big flat screen 4K.
Actually, when I was holding my tubes up to the camera before we got online, I noticed that there was a weird blue reflection on some of them, and I was trying to figure out where it was coming from, and I realized it's from this 32-inch 4K monitor over here that was displaying a blue desktop pattern. Jeez. So I had to put up an application with a black background to maximize it to get rid of the reflection. But no one knew how to do that. And the first technology that anyone ever thought of was plasma, and plasma is kind of closely related to how CRTs work, but it turned out not to be practical. First, it was very expensive to manufacture, and then it turned out that plasma screens burn at like 5 times the rate CRTs do, where if you show the same image for a long period of time, when you turn it off, that image is still there. Plasma sets do that like 5 times faster than cathode ray tubes. So
whenever
but then they invented
I was gonna say playing video games. So, like the sniper scope, I've burned that onto TVs before and been like, oh no.
Well, that's one of the things LCDs don't do, fortunately. But in order to make LCD panels this size work, they had to figure out how to actually embed transistors into the panel for each pixel of the LCD to get enough electrical signal to each pixel to get that change in brightness. And that was a thing because all through the 80s and 90s, they were working on new ways to fabricate transistors, new ways to fabricate other devices, LEDs. For years, a blue LED was the holy grail of the electronics industry. By 1960, they had red LEDs and they had green LEDs, and if you used both of them at the same time, you could get yellow light. Mm-hmm. But if you could get a blue LED, then you could make any color. You could make white light. Mm-hmm. And LEDs could change brightness very fast, unlike light bulbs. So you could make very small picture elements and you could change them very fast, and you could make a television set if you could get a blue LED. They worked on it. It was like the holy grail through the 80s and the 90s. And it wasn't until after the year 2000 that the guy in Japan finally solved the problem. And he did it by leapfrogging everyone else. Because when you're looking to do a thing like generate light from a diode, there are certain chemicals that are attractive and that already work, or that are related to the ones that already work because they're in the right column of the periodic table, and they have various electrovalence numbers and magic hopscotch like that. So there were 2 chemistries that were considered to be promising for short wavelength LEDs. one of which was fairly convenient to work with, and so it's the one everybody was using, and the other of which was highly toxic and corrosive and just an absolute nightmare to deal with in the lab. So this one guy in Japan decided, well, everyone else is going with the easy shit and it's not working. Let's see what we can do with the hard shit. Mm-hmm. And he had to invent his own glassware, making shit out of quartz to, because these chemicals are so corrosive. But in the end, what he got wasn't a blue LED. He got an ultraviolet LED. So he actually leapfrogged their goal. Wow. And so nowadays, all of these high-performance LEDs that didn't even exist 15 years ago, this whole ecosystem that has – I can tell you, if you went back to 2005 and found any engineer and told them, oh, yeah, man, I'm from 20 – by the way, don't go to 2020. It's a mess. But in 2020, we can go into the convenience store and buy this light bulb that has actually got a circuit board and a ring of LEDs in it, and we plug it in where we used to put an incandescent light bulb, and it works better. They would look at you like, pull the other one. Yeah, seriously, right? No, LEDs can't do that. Yeah. The idea that we're using LEDs for area illumination is like mind-blowing. Yeah. And we've only been doing it for 10 years. Now everybody takes it for granted. It's like, but what a lot of people don't know is that, for all those years, we thought the secret to a white LED would be the blue LED. So you could put red, green, and blue in the same package and get a white light. That is how they do it for color changing LEDs, like those Christmas lights and all that can change color and make any color. But if you buy a white LED light bulb, there's no blue, red, and green in it. What they do is they take the ultraviolet light and shine it on phosphors. And they phosphoresce, and they absorb the ultraviolet light, and they re-emit it in whatever colors humans can see we want. So they use the same ultraviolet LEDs to make soft white, warm, different colors, whatever, by using different phosphors. And a lot of the improvements that have been made in the last 5 or 10 years have been in phosphor technology. So the LEDs, they've improved too, but there's this whole interlocking set of technologies that have just been galloping together into capabilities that would have been considered ridiculous. They just installed a bunch of street lights on the Lake Pontchartrain Causeway that are LEDs for street lights. I mean, it's like they're bright enough to be freaking street lights. And it's like, no, this is the thing that you have on the front of your radio to let you know that it's on. Yeah. Jesus, you don't light up the damn street with it.
Yeah, it's, goddamn. I was just like, it's one thing I have to keep them in something just because they're so small. But you want to finish this up at 7:30 my time, and we can resume next week?
Sure.
Because I haven't eaten today. I need to get some dinner.
Yeah, because I've about done my show with these guys now. There's a couple of them that here's a little. I thought this guy was just kind of hilarious. That's 3 triodes in one envelope. That was obviously done for some specific purpose in some device that they wanted to minimize the component count. And so there's a whole variety of tube. This combination of elements was useful to them.
It's just one thing I was thinking.
Before there was integrated circuits, integrated vacuum tubes.
128 gigs.
Uh-huh.
And
oh, yes.
And I got this in 2017. This isn't even new. This is 3 years old.
Mm-hmm.
It's just, look at it. 128 gigs. Holy fuck.
And that's gigabytes, which tells you that there are 1,000 gigabits.
Yeah.
Which is what, an attobit? It's like, but they're really dinky.
5 terabytes?
Mm-hmm.
That's insane. And this isn't even top of the line shit. This is like bargain bin.
Yeah. My first hard drive was 10 megabytes, and it was in an enclosure about a foot wide, a foot deep, and 4 inches high, with its own power supply and all.
Own power supply?
And man, people thought that was rocking, man.
10 terabytes, $109.
Yeah.
Just nothing. There's just an extra 10,000 gigs.
Yeah. But man, it's surprising how fast you can eat that when you're recording 4K movies now, isn't it?
Uh-huh. I put away about 40 gigs per episode. Because I save the main file that I break everything off of. So, like, the low fidelity shit, the ones I upload to YouTube. I have, like, it's like kind of like Prime Intellect. I have, like, the Prime file. And everything else I sort of shave off of it. But I keep the Prime. So, in the future I can come back and I still have this, like, 4K screen recording that I don't need right now. I couldn't possibly upload in any sort of timely manner. But I keep it just for the future.
Yeah. Well, it gives you a better basis if you start editing or you need to do something. It reduces your losses.
Yeah, I just keep the big boy. I just keep the Prime file. They run about.
It shows your video. Your videos do look good. I mean, especially considering I know you don't do a lot of post processing on them, so you're doing something right.
Woo! Thank you. But yeah, I keep the primary file, and but yeah, it's about 40 gigs an episode. Push about 200 a week. I thought you would like it. So I dropped that big one last week and it started fucking up and I was like, "Oh no." So I ordered some like heavy duty ones just to back everything up. Only 4 terabytes. It's big. Shockproof, waterproof, dustproof, throw it across the room. But
the thing you got to watch for, particularly avoid, is shocking them while they're spinning.
Yeah,
they're pretty rugged if they're not spinning.
Yeah.
You can drop them a few feet and they'll usually be okay. But if you drop one of those puppies when it's spinning and the heads are out, it'll just dig canals in the magnetic medium and it's
just fucked.
Just go ahead and throw it away.
Yeah, it's fucked. But I thought about Metamorphosis of Prime Intellect. And where did you put the copies? Intergalactic space. And so I have several hard drives, but I got these heavy fucking duty ones just as like I'm keeping them as copies. And I got this. It's called a dark bag, and it's for it's a Faraday cage bag. And then I got
always worthwhile.
Yeah, and then I got a fireproof, waterproof bag. That I keep it in.
Nested levels of protection.
And on its way is a safe. So, just a little one, size of a microwave.
I don't know if I mentioned it. One thing you will appreciate about Prime Intellect is that one of the things I was a little worried about when I finally got around to writing it was that the scale of the enterprise that Lawrence needed Chip Tech to create for him was not really as believable as it had been when I had the idea, because the idea originally was that Lawrence is very dependent on this industrial company, this massive investment in order to realize his dream. And even in 1994, I was starting to realize that you might not need that much of a massive investment to make it real. So when I first had the idea in 1982, I decided that the change occurred in 1988. Which would have been, in the future at the time, but not too far.
Yeah.
But when I wrote it in 1994, I thought about it a bit, not so much when I wrote Chapter 1, but when I got back to write Chapter 2. Mm-hmm. And I was thinking about, well, is this massive complex really necessary? Is the technical guys and the business guys luring him with this and the military guys, does this really make any sense if computers aren't that resource intensive to make one this big?
Yeah.
So I decided that it's not a big deal in the story. There are a few subtle cues, even in Mopey, that the change occurs in 1988. The president who resigns is Ronald Reagan.
Yeah.
And I don't make a big deal about that, but there are a couple of cues in some of the background that it's not the modern world that these people overrode. So this is a world where 9/11 never happened, Hurricane Katrina never happened, obviously COVID-19 never happened. It was also a world where the Cold War was still, if not hot, still a big topic. I think it's sort of up in the air whether the Berlin Wall had fallen at the time when Prime-elect does the change. But whether it had or hadn't, then you still had a lot of that sensibility floating around, the animosity between the former nation states. And these people who were experiencing the change and going into this new world would be coming from that perspective. So that's also the whole thing with the regional conflicts that are being interrupted because Prime-elect is turning all the weapons into flowers and shit like that. It's like, that's that world. And it's significantly different than today's world. But I didn't want the technology to be a big bug. So in the sequel, that'll be a little more obvious. I'm still not going to make a big deal of it being a period piece. But one of the things that I told the guys that optioned it was my view of it is that the parts that are set before the change are a 1980s era period piece, because otherwise the technology starts making less and less sense. I mean, we are almost at the point today where you could put a computer on your desktop that is as powerful as the Prime-intellect complex. And you don't need them to have speed of light processors because the thing is so small. That was a thing. If your computer's the size of a warehouse, having things 300 feet apart becomes a problem with the speed of light. But if it's a microprocessor and it's that big, it's not that big of a deal. So, but it's like the big deal that is made about Prime-intellect being able to do real-time video and render a face, and it's like, your fucking iPhone can do that today.
But I think as long as it's understood what period it's in, I think the weight will hold the same. Like 2001: A Space Odyssey, like as long as you know when it is. Or at least when it was written. To me, it still makes the story awesome. I didn't want it to be in everyone's face. But I also didn't want it to be obviously in a modern era where it didn't make any sense either. So it's as much about things that I don't mention because they don't exist in that universe as things that I do. Well, you're right. There's not a whole lot of, or if any, specific dates in it. I don't know. I never thought about who was president. You said Reagan, but as soon as you said that, I started thinking, I didn't even realize it, but subconsciously I had put George H.W. Bush in that position when you said around noon he retired or resigned. I just put H.W. without even thinking about it.
It depends on when in 1988 it was. Actually, H.W. didn't get inaugurated until 89. And in my headcanon is that it's 88, so it would have been toward the end of Reagan's second term. It might have been even after the election.
Lame duck.
But the main thing is that, and Reagan is also a person I could actually see doing that, because he is a trained actor. I mean, in a certain sense, he was paid to play the president for 8 years and did it professionally. And he knew that he wasn't actually making all these decisions. He was the face of the presidency. And so I can see him going, guys, the gig is up.
We had a good run.
The show is over.
We had a good run. We did good. All right. We got us to Nirvana. We got us to Nirvana. We did our job. We got to Nirvana.
And the show is over. There's nothing more for me to do. It's like stage curtain comes down. He would see it that way because of being show business. That was his background.
Designed at noon.
HW would have probably been a little more reluctant because his background, he came out of the CIA and the intelligence.
He would have made sure
agencies and all.
He would have made sure the Scarecrow call went through. He wouldn't have liked that. He would have been like, fire the nukes, the B-83.
At the very least, he would have stuck around to make sure he knew why. Reagan is very much, when you kind of look around, guess that's it. That's kind of my take on that.
Kind of maybe messes up the hair, takes off the coat, and he's like, kind of that gig is over. Like White House is the set. He's walking off set.
And the other guys are going, no, Mr. Reagan, we got it. And he's just like, what?
Guys,
what are we doing now?
It's done. I'm going to L.A. I'm out of here. We did it. It was fun. We beat the We beat the Russians, kind of, sort of, not really. Whatever. We're finished.
did kind of.
Yeah. Yeah.
So anyway, that was a thing. I didn't recall whether I had mentioned it that I thought you might appreciate.
Yeah.
So yeah, but that's the whole thing about all the stuff I've been talking about so far is about how technology mutates and how it evolves and progresses. And within living memory, we've gone through several generations of things that had been previously inconceivable becoming real, and then those becoming obsolete and something else inconceivable becoming real. Right now, we are about at that point where we were with vacuum tubes in 1955, where it was a mature technology. You didn't have a lot of new original research being done. You just had more engineering designs done to sharpen the price point of consumer devices and stuff like that. And that's kind of where we are with computers today, until another shoe drops. And just between you and me and that flag in the background, where I think that's going to come is probably going to be diamond instead of silicon as the substrate for semiconductors. Once we are able to make diamond wafers and dope them and etch them the way that we can do silicon wafers, they will be able to handle higher powers, higher frequencies, smaller design elements. Everything about diamonds is superior to silicon performance-wise. The difficulty is fabricating pure crystals, because for one thing, there are companies working on this, and they are in a constant tug of war with powerful people who very much do not want people creating large, pure artificial diamonds for completely unrelated reasons.
Yeah. We got to hold on to the grip. We can't have them knowing that they can synthesize this stuff.
I remember reading an article about that whole phenomenon about 10 years ago, and the reporter who visited the company who was doing the wafer, the wafer technology, made him go to their factory in a van with no windows, wearing a blindfold, so that he wouldn't know where it was. And they were just like, dude, we can't let the De Beers people figure out what, if they figure out what we're doing,
they'll kill us.
Then
they'll kill us.
There's no telling how they will react.
They will hire some mercenaries. They will kill us.
This is a realistic fear.
That's not bullshit. That's Tom. Who is it? Tom Ogle, the guy that made the car that ran on water.
But well, that's a may or may not have been a daffy conspiracy theory, but the diamond thing is very real. And these guys were like, we don't give a shit about De Beers' business. That's not what we're trying. We are not trying to make pretty things to hang around women's necks. We are trying to make the next generation of electronics devices that will change the world. And the fact that they will start with a pretty crystal is not our problem. So anyway, we are in for another shift of that nature. And of course, that's one of the things Kurzweil bangs on about in his books, that we are probably one of those steps away from being able to create an artificial brain that is the size and power consumption of a natural brain. What we don't have, we could probably already do a large one like Prime Intellect, where we use a much larger computer to emulate. But there's also a software revolution needing to be taken place. And I tend to believe that the people who are investigating AI are barking up several wrong trees right now, because nothing about the natural scheme was ever designed. And everybody is off trying to design things. They're trying to design video handling modules. They're trying to design things that would handle this, that, and the other. And I think what we need to do is let it discover how to become functional, because I think this is a thing that has evolved separately several times, and you've got very different animals at very different scales of complexity that are all doing very similar things rather. And we just happen to be the most complex expression of that. But that doesn't mean we are all that unique. If you actually interact with animals at all, then that, dogs and cats obviously have emotions. They obviously think about things. They're capable of cognition. I like to think that of what they do it at what I like to think of as a lower resolution. So they do what we do, but they do it at a lower resolution.
It's like 144p.
So they can't think as far ahead. They can't perhaps recognize as many things as we can, or classify as many relationships between things in the world. But within their limits, they do very similar things to what we do. And we have parrots, including an Amazon who does talk, and he interacts with people in very human-like ways, considering that his brain is about the size of one of actually it's a lot smaller than that. Then it's pretty remarkable that he knows what a lot of these words mean. And he very definitely does know what a lot of his words mean. Now, some of them means just like, okay, cookie means food. He asks for a cookie when he wants food. But it's very plain that this is his language. This is the way that he's absorbed and adopted it. And, of course, you've got Alex the African gray that was able to, he basically smokes the primates at natural human language, not least because he speaks English instead of Amelsan, or spoke. I think he finally died. But there's a lot waiting to be discovered. Is what I'm circling back around to, and the gulf between this and where we are today is probably smaller than the gulf between us and something like prime intellect. At this point. I think we're closer to that point than we were to today when this was the state of the art.
Now, do you think that in time, or do you think that in technological progress? Because it might be farther technologically, but shorter due to accelerating progress.
I tend to think those are closely related. If you look at things like your hard drive there and all, that was an unthinkable storage density 15 or 20 years ago, and the hard drive. Basically, you can go to every point in computing history in the last 40 years, and wherever you are was unthinkable 10 years before. Hilariously, when I was in college, I was cruising the backstacks at the college library at UNO, and I found the Proceedings of the American Computing Society. And I found some they had old issues going back to the 50s and 60s, and I found an article from like the early 60s about some university research group or something that had built a 1 kiloword random access memory store. And what an advance this was, because memory stores that large were things like ferrite core, whatever. They took time to read and write and all. But this was actually, solid. This was actually electronic RAM that could be updated quickly, and the algorithms that we would be able to research on this machine were totally new. And at the time, I had a whole tube of 2 kilobyte static RAMs in my closet, and they were obsolete. So, and of course nowadays I've got a whole tube of 256 kilobyte RAMs in that same pin factor, and they're obsolete. So it's like when I repaired my I have a single board computer demo thing. Our Cosmac Super Elf. When I repaired it, because when I got it, it had a bad memory board and no native chips, I actually had to install a memory chip on it that was anachronistic and too large, because I couldn't get the obsolete ones that it had been designed to use. So I had this board, and to make it work, I had to flip it over, and on the back of it, I have a more modern IC, hot glued, and I have all the wires hand, dead bug hand wired to the right points to use it. And that was, the difference between the mid 70s and the mid 80s.
Yeah, it's insane.
And of course, nowadays my wristwatch could cheat this thing at poker, and I don't even have an iWatch. That's just my LCD timekeeping.
Yeah. I mean, like, what the fuck is just in like this AirPods case? Just probably more than anything. Yeah.
Yeah, and the thing is, it's like I got a lot of these tubes by driving around the neighborhood and looking for people who had thrown TV sets away and stuff, and I would snarf them up and then clip all the commands. So I hold drawers of parts from this that I'll never use because they're so obsolete. Half of them are bad now because they don't keep well.
Yeah.
Ironically, vacuum tubes are among the most stable components. If you aren't powering them up, they don't go bad. They don't wear out. As long as you don't break them and let the air in.
Yeah.
That's why this 90-year-old vacuum tube still does what it did when it was new. And modern components, that's one of the things that we don't do very well. I was talking with one of the engineers at one of our manufacturers that my company represents about their design challenges and everything. And he said that one of their suppliers had pointed out that there is a special class of capacitors for cell phones. And it's not that they work better. They're actually crappier and cheaper than normal capacitors for regular work, but they know that you'll probably throw your cell phone away in 2 years, so they don't have to last as long.
Yeah. Planned obsolescence. Yeah. Doesn't matter.
It's like, there's a special class of especially crappy components that are made for cell phones because your cell phone isn't expected to last more than 2 years.
Yeah. Fucking A.
There's that. Anyway.
Well.
I think you wanted to wrap it up, so
let's wrap this.
I'm getting hungry too.
Yeah, let's wrap. Yeah. My mom made some soup. It's like I think it's like chickpea and like sausage. I don't know, but it smells fucking delicious. And that's how you know we're still. Yeah, that's how you know we're still far away from prime intellect. As I still run on this glucose and protein substrate to make my computer work. Laptop can go indefinitely, and I'm like, I can smell through my olfactory sensors. I'm like, glucose, Yeah. So, sorry for anyone that had to see that. Let's same time next week. Delve into more technology.
Let's do it. Maybe a little history of the porn industry too.
Fuck yeah, dude! Like, fuck yeah, that'll be awesome, dude. Got nothing but time. This podcast isn't going any. Knock on wood, this podcast isn't going anywhere. Well, now that I'm building, I'm calling it NORAD. That's what I'm calling the safe with the hard drives in it. Now that I'm building NORAD, we can fucking, doesn't matter. I can store this shit forever. House can burn down, get flooded, fire. It's got EMP protection. This thing is turning in. I am sowing the seeds of an embryo for prime intellect. It's forming. It's forming right now.
Yeah. When we came back after Katrina, the storm had blown one of the gable panels off the side of my attic, and my fireproof safe was just sitting there in the opening, like just sitting there, right? Because it had been against the wall, and the wall was gone. So I just drove up in the neighborhood, and it's like the first thing I see is all of my private shit, just sitting there waiting for someone to steal the whole safe. It's like,
that doesn't work well. Yeah. So I'm getting the one I'm getting. It's fireproof and waterproof. So I figure if it's on fire, it's gonna get put out with water. So I'm protecting against both. And
that is the idea behind those. Yes.
Fuck you. Fuck you, Roger.
Woo. They're also rated by the length of time it takes to break into them, which is never infinity.
No, you're right.
Any safe can be broken, so part of the rating is the time it would take a professional safe cracker to break into the safe.
Yeah. Well, if they want to steal my hard drives, I mean, you're not finding any De Beers in there. You're finding a bunch of episodes like this talking about the history of porn. So, I mean, I think that's my biggest safety is no one's trying to take it.
I hate losing data, man. That is just like the most heartbreaking. That you realize that you put a bunch of work into something and you don't have a copy of it anymore because it's like ephemeral, and somehow you lost the last copy, and that just, I mean,
it's tragic.
I can't bring myself to try to recreate it sometimes just because it's so heartbreaking. I'm just like, no, I'm done with that project. Screw it.
It's gone. It's forever. It's don't try to bring it back. It's gone.
It's lost to the ages. Whatever. I'll do something different.
It's contact. So. It's floating out at the speed of light with Hitler's speeches. All right, Roger Williams, author of The Metamorphosis of Prime Intellect, will be in the bio and in the top comment. My favorite story. It's badass, and as we creep closer to the future, I think it's becoming more and more of a reality. To be continued next week. Pornography, diamonds, the future of technology, and whatever the fuck else we want to talk about.
Hey, it's been fun.
Fuck yeah, Roger. Thank you again for doing it, man. I love having you on. It's so much fucking fun. I forget that you're the author of my favorite book, and that just adds an especially awesome tint to it. But fuck yeah, man. I can't wait for the next one. Thank you for the show until today, and let's get right back into it next week. Peace, buddy.
Sounds like a plan.
Godspeed. Stay safe.